All right, in today's lesson, we're going to be looking at how we can solve contextual problems. And again, contextual problems are real life situations, so there's going to be a restriction on the domain and the range. And again, we're usually going to be hanging out in quadrant 1. Okay, so we're going to be using the graphs of quadratic functions to solve contextual problems. And specifically, we're going to be getting some important points off of that graph, such as the y-intercept, which represents the initial value, typically. The vertex, again, the x-coordinate is the axis of symmetry, so it represents the independent variable value at the maximum, and of course, or minimum, and of course the y-coordinate of the vertex is either a maximum if the parabola opens down, or it's a minimum if the parabola opens up. And of course the x-intercepts. So the x-intercepts, or the roots, become quite important. So I just want to note that we're not always going to be using all the points, okay? It's going to be based on the situation. So you really do have to read the question carefully, okay? And then based on what the question is asking for, you will get the points off the graph, and that will represent the answer. And all I'm going to remind you to do is that in your final answer, that you make sure that your answers are rounded and you use proper units based on what the question is asking. So there's kind of two ways that we go with this. Number one, we start with an equation that we're given. The other option is that we are given important points on a graph and we have to build the equation. And so there's going to be a later lesson on that. It's going to be a little bit different than what we're doing today. However, for today, we're going to be looking at scenarios where the equation will always be given, okay? So kind of the general strategy, I guess, would be that you start with the equation, you then get that equation into Desmos, you graph it, you then snip the graph and put it into your Word document, and then get the important, like after you got the important points, and then you go from there. So in today's examples, you'll notice that the equation is given, okay? And so if you're wondering what do we do when the equation is not given, we'll be doing a later lesson on that this week. Okay, so we'll begin. Our first example, we have our context. A cannonball is launched out of a cannon that is elevated 6 feet above the ground. The height of the cannonball h over time t is modeled by the following equation. H equals negative 4.9 t squared plus 70.54 t plus 6. So you'll notice right away that this is a quadratic equation because we have the t squared. It's in standard form. We have a, we have b, and we have c. And so notice that the cannon is elevated 6 feet above the ground. That's the initial height. And the value of the c is 6, so it's the same. So essentially, the cannonball's initial height would be 6 feet. All right. You'll notice that you don't see x and y. Again, y is always the dependent variable. In this case, it's specifically h, height. Okay, so h is the same as y in this case. And t is our independent variable, time. Okay, so t would represent x in this case. Okay, all right, so t is like x, h is like y. Okay, so we can type this in, y equals negative 4.9 x squared plus 70.54x plus 6. And you'll notice that we don't really see the graph, so we're going to have to scale this. So the maximum point, okay, goes up to about 259. So I'm going to set my y max to be 280, and it crosses the x-axis at 14, so I'll say 20. So always want to fix our graph. So we'll go from -5, just so we keep the keep some of the x and the y-axis, to 20. The y and the h-axis is time in seconds, and the y-axis will go from -5 to 280. Go. Actually, we'll make that a bit bigger. And the y-axis is height in feet. Okay. All right. So we have then our graph done. Okay, and we can now go ahead and start solving the questions. So we read the first question. It says, determine the maximum height the cannonball will reach and at what time it will reach that height. So the question is asking, first, find the maximum height. This is going to be the y coordinate of the vertex, okay, because maximum. And if you look at your Desmos graph, it goes up to a maximum. So the y coordinate will be the maximum height. Second, find the time at which the ball is at maximum height. That is the x coordinate of the vertex. Okay, so the bottom line here is we need the vertex coordinates. Okay, so the good thing about this is that it's very easy to get the vertex coordinates. You just click on the vertex. Okay. There. Okay. I made the scale it bigger so the graph doesn't take up all the space. All right, so we click on, okay, sorry, and we gotta hang out in quadrant 1. So we have to put in our restrictions. Okay, always remember that. So x greater than or equal to 0. And then, whoops, undo that. And then click outside, and then y greater than or equal to 0. Okay, so we need that. And there we go. Alrighty. So we click on our coordinate, and there it is. So that's the coordinate of the vertex, and we will snip that. Make sure we get the labels in. And we got that. Copy it and paste it into our Word documents. Okay. Alrighty. So the vertex then coordinates would be 7.198, comma 259.872. Okay, so now final answer. So I'll put this in a different color, red. So we see the maximum height would equal the y coordinate. So it's 259.87. Again, we want to round to 2 decimal places. So 259.87 feet. Make sure we have units. Okay. And the time would equal 7.198. So we have to round the 9. So it's going to be 7.20 seconds. That would be our final answer for part A. The maximum height of the ball is 259.87 feet, and the time is 7.20 seconds. And again, we got this from graphing the graphing the quadratic function, and then finding the vertex coordinates. So that is a standard type of scenario where we just have to get the answer from one of the important points. Okay, we're going to move on with the second example. Determine the amount of time that the cannonball is above 180 feet. Okay, so if we go back to our graph, you'll notice 180 is about right here, and the height, it goes above 180 and then it comes back down. Okay, so there is an amount of time where the ball is higher than 180 feet. Okay, so how are we going to get that answer? And the question is asking for how much time. Okay, so that is an x value. So to solve this, we need to input the equation y equals 180. Okay, and we do this because height is a y value. And we are solving time, which is an x value. If we were asked at what time, because we're given the y value, we have to write the equation. If we were asking, well, what is the height of the ball at 3 seconds, then we would type x equals 3, okay, because we're given the x. So whatever value you're given, you type that into Desmos as an equation, y equals or x equals. Okay, so I'll show you how this works. So we're going to say our height is 180 feet, so y equals 180. And you'll notice, I'll just turn this into a red, there we go. You'll notice that it touches the line, or sorry, the curve, the line, horizontal line, 180 feet, touches the curve twice. So when the cannonball is launched at 3.161 seconds, it hits 180, it goes above 180, comes back down, and hits 180 feet in height at 11.235 seconds, and then carries on. Okay, so there are 2 times at which the cannonball is hits 180. So then the question is asking, determine the amount of time that the cannonball is above 180 feet. So we want the time, okay, from 3.161 to 11.235. So how do we get this? Hopefully you're realizing that we're simply going to take the 11.235 and subtract the 3.161, and that would give us our final answer. So notice that we don't just click on the curve and get our answer. We actually have to use the points to get our answer. So we have gotten the points, and we need these points, so we're going to snip this and put this into put this into our Word document. Okay, and we can begin. So time is an x, so we're going to say that x1 is the time at which cannonball is at 180 feet the first time, and x2 is the time at which the cannonball is at 180 feet the second time. Okay, so first time, x1, second time, x2. Again, this is putting it in context for us. You don't need to write this part out, but I'm just doing this for learning. What you do need to state is the x1 and the x2. So x1, okay, is the x coordinate 3.161, and x2 is the second coordinate x 11.235. Okay, so it's very important here that we are using the x value because we're solving for the amount of time. Okay, so now the amount of time is going to equal x2, which is 11.235, and we're going to subtract x1, 3.161. So 11.235, and we'll subtract 3.161, and you get 8.074. 8.074, and so our final answer is the amount of time cannonball is above 180 feet is 8.07 seconds. Again, 2 decimal places, please. So we're rounding that 7, and make sure you include units. So 8.07 seconds is our final answer. So this is a second example where we've done a little bit more work. We've done a y equals, and we've gotten the intersection points. So back over here, we call these the intersection points. So it's pretty simple, okay? When you want the answer, okay, if we work backwards here, you type in y equals 180 in this case, because that is your height. It could be whatever it is. And then you just literally tap on the intersection points and you have them. So it's pretty straightforward on Desmos to get those points of intersection. So that covers off example 1. Okay. Example 2. It's a bit of a different scenario. This is actually question number 13 on page 407. So I'll write that in there. It's number 13, page 407, in case you are interested in this. All right. So Sanella sells posters to stores. The profit function. Okay, so P is profit, N is the number of posters. So the profit equals the equation negative 0.25 n squared plus 6n minus 27. So profit is the dependent variable y, and n is the independent variable x. In this case, P for profit, N for number of posters. So we'll look at the scale here. N is the number of posters. Okay, so N is the number of posters sold per month in hundreds. So if N is 3, then it would actually be 300. And PN is the profit in thousands of dollars. So for example, P, if you have 28, that would be 28,000. Okay, so that's sort of how the graph is going to be scaled. All right, so the first thing we should do before anything is get this into Desmos. And so if you don't want to type it in exactly, again, we can say that P, profit, is the dependent variable. So therefore Y. And N is the number of posters, which is the independent variable, which of course is X. So we could replace Y for Pn and X for N. Either way, we've got to get this equation in there. Okay, so we go back to Desmos. I'm going to keep this, so I'm going to copy. I don't feel like typing that again, so I'm going to copy that, and then I'm going to reset the graph. Okay, so we have to type in our equation. So y equals negative 0.25 x squared plus 6x minus 27. So talk about the minus 27. Interesting that the y-intercept is way down here, minus 27. But you're thinking that we can't have negative, we always have to hang out in quadrant 1. But in this case, okay, P is profit. And of course, if they don't sell any posters, it does cost money to sell posters. So if they weren't to sell any, if Sanella wasn't going to sell any posters, she would actually lose the $27,000. So that would represent, okay, lost profit based on not selling any posters, okay? So even though we are hanging out in quadrant 1, this negative 27 does mean something because of the context. The context is P is profit. If we go back to example 1, H was height and time was X. So the X, of course, can't be negative because you can't have negative time, and H has to be nothing bigger than 0 because height is defined as the distance above the ground, and the ground is defined as 0. If the object went burrowing its way into the ground, that would be negative height, but that's not realistic because you're not going to be essentially doing that. So height is defined as the distance above the ground, so therefore quadrant 1. Whereas over here, P profit, you can have a negative profit. Money value profit represents how much money you make for selling something or providing a service. You can lose money, so that would be a negative value. So that this specific example, when there's money, it could be hanging out in the negative range. Okay, so just to note that. Anyways, we will scale this graph a bit better. Okay, so we've covered off that y-intercept. We are now just going to focus on quadrant 1. So we will go x-axis negative 5 to 20, and the y-axis will go from negative 5 to 20 as well. Okay, and don't forget, of course, to label. So x is the number of posters in thousands. Nope. Posters is in hundreds. And the y-axis is the profit in thousands of dollars. Okay, so that is that. We have our graph good to go, and it's scaled. Let's go read the question. A, how many posters must Sanella sell to break even? So to break even means the profit is $0. Oops, put the $0. That's what break even means you don't make any money, no profit. So here on the graph, how do we find that? We look at the x-intercepts. Okay, so we look at the x-intercepts of the graph, and there are 2 of them. Okay, 6, 0 and 18, 0. So we will snip this graph. And copy it into our Word doc. And we have our x-intercepts. So x1 is 6. x2 is 18. So how do we solve this? It says how many posters must Sanella sell to break even? All right, so the 6 is not 6 posters, but 600. So 6 times 100 equals 600, and 18 times 100 is 1,800. So the answer, to break even, Sanella can sell either 600 or 1,800 posters per month. And why would she make less profit by selling more? Well, of course, again, remember, it costs money to make posters, so her production costs are going up. So this is an interesting model because you'll notice it's a maximum profit. So of course, anybody that's in business of selling something, okay, is always interested in that maximum profit, that sweet spot. Okay, so that would be the ideal amount to sell. I hope you guys realize that. So that is our answer there. And we'll move on to part B. So part B is asking if Sanella wants a profit of 5,000, okay, and again, remember 5,000, we have to enter 5 for Y because Y is the profit in thousands of dollars. So 5,000 divided by 1,000 is 5. So how many posters must she sell? So this is going to be a Y equals 5, okay, and we'll plug that into our Desmos. So again, we're going to type in Y equals 5 on our notes. We're going to go to Desmos, so I'm going to go Y equals 5. And you'll notice that it touches the graph twice. So we're going to click on the 2 points. There we go. And we'll take another snip. Okay. Copy that. put it into put it into our Word document, and you'll notice that whoops, so that's a little small. Okay, and you'll notice that we have two answers. So our number of posters is X, so our X1 is 8, our X2 is 16. So our answer is Sinella would sell either 800 posters or 1,600 posters to make $5,000 in profit. Let's see, to make $5,000. Obviously, that's profit. So that it would be the answer for part B. So again, we're doing that y equals, and why is it y equals? Because of course we're given the y value, okay? So y equals 5 because it's in thousands of dollars for 5,000, and then we find the two intersection points, click on them, and then we have the 8 and the 16. So 8 times 100 is 800, and 16 times 100 is 1,600 posters. So that would be for part B. Part C, I believe, is a very similar question. If Sinella wants to earn a profit of $9,000, how many posters must she sell? So profit equals $9,000. So what do you think the equation will be? Okay, again, if it's profit in the equation is in thousands of dollars, we would take 9,000 divided by 1,000, and our equation is y equals 9. So we go back to Desmos, and we will type in y equals 9, and you'll notice that it is touching the vertex. So if you're noticing there that it's getting at the vertex, then you can just literally click on the vertex itself, and that would represent that. So it only touches it once, so that's fine. So I wouldn't type in y equals 9, but I was just going through that example to show you how we would get there. So if you notice that you are asked for the vertex, then you would just click on it. So now we can snip, copy it, paste that into our Word document, and you'll notice that this is the optimum answer. This is the maximum number of posters to make the maximum profits. So in our vertex, V for vertex is 12,9. So Sinella, oops, can't spell her name. Sinella should sell 900 posters to make a maximum profit. Sorry, not 900. I cannot do math. We need the X. So the X equals 12. So Sinella should sell 1,200 posters per month to make a profit of $900, which interestingly represents the maximum profit from her business model. So based on what she's doing, she cannot make anything more than $900 per month. Okay, so that's part C. Last is domain and range questions. So it's asking, what is the domain and the range of the profit function? And again, in context. And now, usually we do only hang out in quadrant 1, but remember we started here. We can, for the range, go down to -27 because that represents the profit lost if she does not sell any posters, because of course, she's gonna have to make a minimum of 600 posters. So if she makes 600 posters and doesn't sell them, then she's going to lose money. Okay, so there is a minimum amount, okay, of posters she's going to have to sell to offset her production costs. So we do, for the range, have to account for that -27. However, for the domain, you're not going to sell negative posters. Okay, so X will be greater than 0. And we probably wouldn't go infinite, okay? You're not gonna sell an infinite number of posters. So we do wanna keep it in context. So we could essentially go to the second x-intercept, because on this model, why would you sell anything more than 1,800 posters? Because now you're gonna lose money. So it would make sense then that the domain goes from 0 to 20. and the range goes from negative 27 up to 9. So in context then, the domain would go from 0 to 18, and the range would go from negative 27, which is that profit lost if she doesn't sell any posters, to 9. That would be the domain and the range in context. It said to explain, I just did it verbally. Okay, you could just be asked to write a sentence. Now, typically for domain and range, I would just ask you for the domain and the range in context without an explanation. However, again, if you had to provide one, this is what it would be. The domain would go from 0 to 18, because of course she could sell 0 posters, okay, not sell anything at all and lose $27,000, and she could make 1,800 posters per month. Anything more than that, she's going to lose money. So the domain in context is 0 to 18 inclusive, and the range, all right, is the negative 27, which represents the profit lost, negative $27,000, all the way up to a maximum of 9, okay, which represents $9,000. So I wrote that wrong, sorry. All right, so domain and range in context. All right, starting with a function, finding an x value given the y, using the vertex, again, for a scenario with an equation. So that would represent our lesson for today. And I hope this makes sense. Go through it, make sure you can do this, and check my website for the practice textbook questions that you should work on for today. And good luck. Thanks for listening.